Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about first ever electric vehicle, basically passenger flight. So let's dive deep into it. Now, this is the dream right now, and the dream is a aircraft that does not fuel, meaning there is no such thing where you're like, okay, here's a pipe, here's you put it in, and here's how you transfer the fluid. No fuel. And the core point of that would be independence from fuel pricing, meaning there are a lot of fixed costs when you're talking about airlines, be it pilot, be it the aircraft itself. There are a lot of fixed prices. You cannot do much about it. However, there is one vector you can do a lot about is fuel efficiency. Basically, if you consume less fuel, you can offer cheaper prices and have larger market share. That's why the two big airlines company, they work their ass off to save as much fuel as possible. So imagine a world where you do not have to worry about it. Like fuel does not matter anymore. So that would be awesome. And what would be the gains of that? Gains would be lower noise floor. Now let that vehicle, it would be lower, not quiet. Simply because if you have seen electric vehicles, once they travel at high enough speed, let's say 100 km per hour or higher, they start to scream simply because you are moving a big massive things through air. Air is not vacuum. It will scream. So fundamentally, if you have something that can travel very high speed in basically atmosphere, it will make sound. So noise floor will go down, but it will not be eliminated. And then you have zero pollution. Now, in terms of pollution, planes have made amazing strides. Only few planes, modern planes, are this toxic. If you're seeing organs fume is a nitric acid or something like that, basically NOx is being reacting with something as not a good thing. This should never happen, but only a Russian plane and SpaceX rocket does this. So if you see giant orange plume, that's bad. So we have made amazing progress. Like basically the modern engines are really good and the flame temperature is low enough that NOx emission is very low. But it's still not zero. But if you go to electric, you can make it zero. Noise will go down and pollution will go to zero. So that is very desirable. And flights will become far more accessible. Now, planes are very accessible, but they have a scale problem to it, meaning they make sense if you are living in a populated area. What about unpopulated area? And again, you cannot have a scenario, nor you should wish for a scenario where everybody lives in city. That would be a hellhole. So for that reason, you do want people to be spread out. And then again, it creates the problem. You will not have enough traffic to justify airports there. So there is a fundamental limit, basically how small of a town can have airlines and all that. So if you can have electric, you in principle can have small crafts like that can just charter you to where you want to go. So that would be a dream come true. So there's a lot of interest in this regard. So Alia CX300, basically this puppy is from Beta. The Beta company was created in 2017 by Kyle Krug. So this company is actually old, and not to mention, it's also huge. It has 800 plus employees, so magnificently huge for a startup point of view. And they have 100% EV, meaning it's not hybrid. There are some companies that are trying to do hybrid, and again, we'll cover that in future. But this is pure EV. There is not a single drop of fuel put into this. And this puppy is 6-seater with 4 payloads, meaning you can have 4 paying passengers, as in this example. And you can have dual pilot configuration. Now, that's generally not done for this sort of small craft, simply because the pilot's supposed to be sane for 1.5 hours, and they generally do not fly for very, very long distance. And it's again, the number of people there is so low that it's like, it's okay with one pilot. If you have 15, 20, I think somewhere around that, they're like, no, bro, you have to have 2 pilots. So this can handle 2 pilots. Again, your paying passenger will go down, but it can be done for legal reasons. And you still have 4 people. And it's a single pusher prop motor design. Now, why they are doing this? Well, they wanted to make sure that it stands out, right? The craft should stand out from all other small Cessna, so to say. So how can they make sure? Well, it's quiet. How do you make it even quieter? Well, put the engine on the back, because again, the air turbulence that you're creating from your proper that goes back. But here's the deal: if your engine is in front, that noisy air, the whole air, buffeting air and turbulence directly hits you. But if it's at your back, it does not hit you; it goes into the air. So it's much quieter. So every passenger that is traveling there, you will notice they are not wearing earmuffs. They don't need to. Like pilots do it because again, law requirement and training, but they don't need to. And again, they do need mics, so they don't need to, because it's so quiet. That's why this pusher design does give them the benefit, where if people sit in this, people sit into other Cessna, they will instantaneously notice it's like, whoa, why this is so quiet compared to other systems. Now, like, then why don't we need that when you are boarding airlines? Well, airlines are huge, and because they are huge, they generally have giant sound insulation layers, like seriously a large amount of insulation is put into them. They can't afford it. So you make it quiet. How do you make it quiet? There is no engine, so it's very quiet. You put it on the back, so buffeting air goes behind you, not ahead, on you, so to say. So that's how they are achieving very quiet operation. Meaning, as a just like luxury cruise is like GG. So this is Alia CX300. So let's understand the technology out of it. Again, when you're talking about electric thing, the core part is where the hell is the battery coming from. Now they are using cylindrical cells, exactly like how Tesla is using. I do not know the chemistry, they have not shared it. So the battery pack is 45 unit, 45 kilowatt hour, and the voltage is kind of high. It's 832 volts. And it does make sense because again, they do want to have a lot of power, and weight is a sensitive topic. They want to reduce conductor size. How do you reduce it? Increase the voltage. So that's why they're using such a high voltage, and they have 5 of these packs, so to say, in a craft. That gives them around 225 kilowatt hour, basically 225 units of power, and it's 1.2 tons. That's heavy. And it can do fast charging for 1 hour, which is like okay-ish, nothing fancy. It's okay-ish. And the motor, the inverter and motor unit, this puppy, is H500A. Now, the critical part is this is kind of efficient, 98% efficient, and it has dual redundancy. Because you're talking about a plane and you do not have pusher, puller, or you do not have 2 props, this motor cannot fail. So it has dual redundancy, meaning not only it has a dual stator in the same chassis, it has dual inverter also, meaning 2 completely isolated things. Meaning if you have any insulation failure that fries one of the stator, second one should be fully functional without any issue. They also have hollow shot for some reason. I think mostly it's for weight saving, but it's a good thing to have. So that is there, 2 inverter, 2 stators, and it's only 71 kilogram, which is decent, not super lightweight. It's not like yay, it's not like that lightweight, but for the power density it's genuinely good. And here's the weird part, like somehow they figured it out. It's air cooled. How the heck they have something that has continuous power rating of 300 kilowatt and is air cooled? That's the most amazing part to me. It's like everything else is like okay, but how the heck they made a motor and inverter combo that is air cooled? That is very difficult to do. Like, and again, efficiency is like not that great. If it's not like 99% efficient, because that means you're talking about 300, you may be looking at like 10-20 kilowatts of heat, 30 kilowatts of waste heat. So that air cooling part is very unique, and a lot of other designs have very complicated plumbing system just to remove the heat from axial flux motor. So that is a very unique thing. And the max power this puppy can do for short duration is 427 kilowatt. That translates to around 572 horsepower. This puppy is fast. Like it can, and be mindful, this is direct drive, meaning this has very high torque. It's not for ludicrously high RPM. It's not like Tesla motor where it's like 20,000 RPM. Nah, this puppy is low RPM, man. It's like it does not even touch 3,000. So it's a very low RPM, meaning idiotically torquey, meaning I do not even want to figure out how many poles it has. Most likely it will have bonkers amount of poles to have that kind of oomph. So it does have that. And they did something clever. It's like they did not have like fancy charging structures. They're like, dude, just use the electric vehicle. So they have this small box for basically you can carry it in the plane itself if you're going into a place for the first time. This side is a normal auxiliary plug used by airlines for aux power. So it's already there in all airports. They have it. And other side would be a normal EV charger. And if you are going there regular, like let's just say you used it in your logistics network, you can have this puppy charging box. This puppy is like a high basically DC bus rail. This puppy can dump around 300 kilowatts of power. So that will give you that 1 hour charging window. This will give you, like, depending on how much power rating you have. If you have 40 kilowatt, that will take some time. If you have 60, it will still take less time. 300 is like 1 hour go. So that's there, and they are utilizing buying charge time. Meaning, in principle, if you buy this and you are living in one of those few places in America where they have like a runway next to their parking spot, you can basically use the same charger that you use for your electric vehicle and your electric plane. It can be done. So that's the tech part of it. And again, range is not that huge. You should know that range is not that great. So eVTOL, they will keep talking about it. It's like, this is just a proof of concept. This is just like, getting the feet wet. We're gonna make eVTOL. eVTOL has become way too attractive to way too many investors, and because of that, way too many companies are pouring money into it, even though physics does not like it. It's because it's a holy grail. The idea is you take off vertically and land vertically, exactly like a helicopter, and you fly like a plane. Why is that? Well, because motor can support much larger RPM window, meaning if you're talking about a helicopter rotor, so to say, it does not have too much RPM range. It goes to a RPM, stays there, the end. Jet engine, it goes to a certain level of thrust, it goes there, stays there, the end. So you do not have that kind of range. Like the range options you have is very limited. But when you're talking about motors, you can have very smooth range, meaning if it's a high RPM motor, you can have like ludicrous range. For example, in Tesla motors, you can have 0 RPM to 20,000 RPM. Even in this sort of high torque system, you can easily handle enough torque to be useful at low as like 100 RPM. So that's a very magnificent thing, meaning now engineers can design a propeller design that can work at such a large RPM range. They did not have this luxury with prop system. Combustion engine systems. So there is a lot of new flexibility available because of motors that people are really looking into it. Now, again, why do we want to do this? Simply because helicopter, while it does give you vertical takeoff and landing, it does not give you efficiency. Meaning if I give you a fixed amount of fuel, you will always travel further, faster using an aircraft. Because again, aerodynamics does not like vertical takeoff or landing. And again, I have no idea how the heck so many people are falling for that. Like, oh, we're going to have this taxi. It's like, what will you do if you have power failure? Be mindful, every civilian airlines have contingency for complete power failure. That's why the rat turbine is there. It's like, what if you kaput the fuel? Rat turbine will provide you power. And again, you will not fall out of sky unless you have a stall condition, which should not happen. And you can easily glide. And again, people have landed successfully. Multiple times have happened where it's like, this happened, that happened. It's like, I got you. In a drone, there is no got you. Even helicopter has like what we call free rotating, which can give you some actually enough control. People have successfully landed. In drone designs, you have nothing. You just go shwing, boom. And yes, it will go boom, because again, you will learn that electrolytes we use in the batteries, they are flammable. So fundamentally, physics and aerodynamics does not like this idea. Meaning, if I give you 225 units of power, if you have VTOL design, it will not go far. No matter what you do, law of physics is like, nah, bro. If you have this sort of garbage adding into the airstream, not talking about the weight, I'm talking about the airstream interference. And again, most of them, they have a design where either the motor turns like this, or in some designs where they're like, okay, they're gonna lock the rotor so it has less drag. I'm like, how about not having a drag? So fundamentally, that's why the only design that can do both VTOL and efficiency of airlines is tail seater. There is no physical change and all that. But again, people will be uncomfortable if you have to sit like this in the airport. So it can work. It's just that it's uncomfortable for people. Awesome for drones. But VTOL will, again, let that be very clear, by laws of physics, if you have the same amount of battery, you will travel much shorter distance. But it has certain use case. Again, you're pushing it, but you can have certain use. For example, air ambulance. It does not matter like how much energy it consumes per kilometer, you will pay for it. It does not matter if like it does not have ludicrously high range. Generally, they do it from place to hospital. So in those sort of scenarios, shut up, take money. Another is rescue. If you need rescue operation, you need the goddamn rescue operation. At that point in time, that capability makes sense. That's why we use helicopters for rescue. So eVTOL is desirable, and again, I blame Elon Musk for this, because again, somehow he convinced the whole goddamn world that eVTOLs are something doable somehow. And now again, investors will not pay you if you're not showing eVTOL concept. That's why every company is doing it. All companies knows this better than anyone else. It's like, yeah, bro, physics does not like this. That's why commercial airlines is just like easy and easy landing. And this like, we're gonna have air taxis that can just like fall out of sky. So eVTOL is like, ambulance, I can say use, rescue, I can say use. Other than that, it's like you're pushing it. Like you're wasting energy, you're pushing it, and it's not even desirable. Because again, when you are hovering, you are very vulnerable. The wings are not generating lift, meaning at power loss. So what can we expect in the future? Now, let that be very clear. It's a very precise tool for the right market, meaning if you dump this puppy exactly where it needs to be, it's going to be awesome. For example, training people. If you want to get people experienced in an aircraft, training is expensive. If you can reduce the cost of the training, shut up, take money. More than air schools are there that are like, give me an aircraft that is cheaper to run. They're like, shut up, take money. More than enough things are there. And again, that was the first target customer for electric aircraft. More than enough schools, flight aviation schools are there. They're like, dude, just give me now. I'll pay you, man. I'll do advance payment for that. So that's awesome. Second is short haul. Now, when I mean short haul, I mean really short haul. Do not expect like hundreds of kilometers, barely 200 kilometers, barely. So the idea is that you're going to have major runway. Nowadays, generally shipping companies like let's say Amazon, they will rent a small amount of space in a civilian passenger airlines. So in that small bucket, they are like, this bucket is for Amazon, this bucket is for Flipkart. So when they land, they take out the bucket. But here's the deal. From that bucket delivery, that happens very quickly. So big warehouse, aeroplane, super quick. Aeroplane to your nearest major city, super quick. Now it has to go by road. So that takes a lot of time. And they are working with UPS to like, what if we do not have to travel by road? What if we go from big airport to small airport? There are a lot of smaller airports and they can easily accommodate this. And you can have enough throughput. And because it's cheap enough, it's actually doable. And again, the fact that it's a cargo, they can afford one pilot. So it can be done. Running cost is low enough. Maintenance on paper is low enough. Now let that be very clear. Electrics always have this issue where it's like on paper it's very low. And if nothing bad happens, it's really that low. But if something happens, it's like electric vehicle. It's like nothing happens, everything is fine, everything is trendy. You had one minor fender bender, and if a high voltage battery gets affected, it's like kaput. The end. Throw away the vehicle. So this will also have something similar. Now again, it's the aviation industry, far more trained people will deal with this, so it should not have too much kaput issue. But again, that part is unknown. As of now, it's unknown. So on paper, it should have a very low energy cost, that is sorted. It should have very low maintenance cost, that should be sorted. Very low noise profile, meaning people in smaller community will not be irritated by this. And it, in terms of ambulance, logistics network, these are like really genuinely useful. And if VTOLs can reduce the noise platform, because again, helicopters do work, they are noisy AF. And a lot of companies are trying to make this. This is also an eVTOL design. That's why it has this weird lump. So if they can figure out a propeller design that can give them the lift without creating a noise hazard, it could work. But again, I have seen the companies showing it and they are always showing it in an open field. So I have press X for doubt. It's like, bro, noise is not a noise if it's like in an open field. Noise becomes a noise when it's bouncing back between buildings. So show me sound in there, that sort of scenario. So, but again, people will put up with the noise. Again, right now, exactly, they put up with the noise of helicopter. So if it's lower than helicopter and not too bad, not too hazardous, it could work as ambulance. I do not have the imagination to see it as a taxi. Everybody else going deaf. And again, that wind is, even if, let's just say you figured out a propeller design that does not scream, what the hell are you going to do with the wind? It's like, it's a lot of wind. Again, if the battery alone is 1.2 tons, I'm pretty sure the whole package is 2 tons or more. You are pushing 2 tons. Bottom is like, ooh. So that's there. Now, let that be very clear. All that being said, this is the right tool for the right job. If any Tom, Dick and Harry tells you that we can do jumbo jet in the future, stop smoking immediately. Law of physics says that you cannot do long haul flight on batteries because assuming you have a magical battery technology that has that kind of megajoule per kilogram, you do not want to be near it. That would be closer to a nuclear boom. Not even joking, that's how much power you have to have. And then how can this plane fly without going kaboom? Well, it does go kaboom. And the reason why this is safe relatively is because it's a half component of a complete equation. You only carry the fuel. The oxidizer is drained from the atmosphere, and atmosphere is not 100% pure oxygen. That's why it's safe, because nitrogen is acting as a buffer. So all these things combined gives you this puppy. Otherwise, you cannot do this. Why? Well, let's say Airbus A380, the biggest puppy we have in the sky right now, and this is heavy puppy. So how heavy? Well, remove the weight of the craft. This can take upwards of 220 tons. 220 tons of fuel for its longest flight, that is generally around 15 to 17 hours. Yeah, and it burns through most of it. 180 ton is just like 180, basically it takes off. By the time it's landing, it's like, I mean, easy. It goes through weight loss, 150 tons of weight loss. So let that be clear. That's the reason why you can have long haul flights, because it gets lighter. So at takeoff, the engines are like, at landing, it's like, easy, bro, easy. So, and it's a big difference, by the way. The delta between basically 1 minute, how much fuel you're burning. At takeoff, it's as in like just after takeoff. Let's say you reach the cruise, you took off, you are at the cruise, how much fuel you're burning versus at the just before landing. It's a magnificent difference. Sometimes it could be as high as 15% or more than that. So, and we were, that's why plane can fly long distance. That's why you can have a plane taking off from one place from India, let's say Ahmedabad, and it can actually travel around 10 to 11 hours and land in UK. Because it gets lighter. Battery does not get lighter. And if somebody did made a battery, let's say quantum supercapacitor, I would not be comfortable with that because it's like too much energy and it's a complete component. That's another part. Again, fuel is safe because it's half component, not full component. You have full component in a battery. So it's like, ooh, ooh, that's like, ooh. So let it be a right tool for the right job. Don't smoke anything. And like, okay, what can we do with this? Well, super simple. Sustainable aviation fuel. What exactly in that? Seaweed biofuel. Nothing else have the theoretical output or throughput or anywhere closes. Like, what if we do this now? Only seaweed biofuel will work. Everything else is just time waste. Law of physics. Let the vehicle. Law of physics. How much we burn. That's why, like, pay attention to how much these puppies burn. 180 tons is like average. Oh, you burned 180 tons of fuel. Figure out how you can get 180 tons for per flight. Yeah, it's not happening. Only seaweed biofuel has the surface area and the energy input and the fact that you do not have to pay for the water, that you can actually do it. Every other designs is just time waste. So this was my presentation on basically electric aircrafts. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra movement. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.